For today's lesson, you are getting your second method for solving for x. I tried to explain in the video last night, you're going to have 4 methods total for getting x all by itself in this chapter. So, and this is what we do all week. We get x by itself. Yesterday, the method you used to solve for x was solving by factoring, where you had to get one side equal to 0, use one of our methods for factoring, and then we used this thing, I called it something, do you remember? The ZPP, what does that stand for? Yes, so you take your factors in your answer that have an x in them and you set that equal to 0 and then you solve. Usually you're looking for 2 answers. I also showed you a little way to check your work last night on the calculator. You're looking for the spot where the spots where the parabola crosses that horizontal line. We're going to do that method again today. So that swung over your head a little bit. We're going to do that again in today's class. So we're going to use that same method for checking that you used in the video yesterday. I will go ahead and let you know that today's method is called the square root method. That's tricky because we also had a square root method for factoring. So let me be very clear. There are 2 square root methods in this chapter. One of them's for factoring. You know, when you had a difference of 2 squares or a perfect square trinomial, you'd square root the first part, square root the last part, bring that down into your parentheses. That was the square root method for factoring. Now we're talking about the square root method for solving. Some books call it solving by undoing. I also say that the technique we have for this is just SADMAP. We're going to go backwards through the order of operations to undo or isolate the variable. SADMAP, you know that's PEMDAS backwards, right? We use this when we solved absolute value equations. Okay, so with that, I just wanted to go over your warm-up real quick. Square root of 100, y'all get that? Yeah! No decimal answers until we get to word problems. Just give me a heads up on that. Part B, square root of 50. Go ahead, Hannah. Perfect. How did you get that? You square root both pieces, yeah. So let's translate that to part D. Square root of 75. What's that? David. Correct. So when you break it apart, how did you break it apart? Okay. And the question you ask yourself again is, what is that largest perfect square factor that goes into 75? And it is 25. So this is 5 square roots of 3. We have a product property for radicals, which is what you were exercising when you did part B and D. I guess let's skip C. For E, we have the square root of 9 over 64. Maddie, do you know how to do that? Yeah, you just square root the top and square root the bottom. However, we get a little bit of a problem that happens with regard to part F. Yeah. Okay, but here's an issue. We are never, ever, ever allowed to leave a square root in a bottom of a fraction. Ever. So I have to teach you this. Oh yeah, about part F. Part F, the offensive part of that answer. Okay, go ahead. Take a little lap back and shut my door. The offensive part of that answer in part F is that we have the square root of 5 there in the bottom of our fraction. So from this point forward, including your assignment for tonight, you want to be very conscientious about never, ever, ever leaving a square root in the denominator. So for part F, it's a nice little example for us to talk about. We have 2 over the square root of 5. And I have to show you how to get rid of a radical on the bottom of a fraction. Hannah, do you know? Yeah, very good. If we want to get rid of the square root symbol, all I need to do is multiply the square root of 5 times itself, essentially squaring the square root of 5. You know, when you square the square root, it goes away. So if I just multiply it by itself, I'm essentially squaring the square root of 5. You could also look at it, if you want to, as the product property for radicals. On the bottom here, this is just like the square root of 25. Which, oh yeah, look at that, is 5. Poof, radical gone. However, what we do to the bottom of a fraction, you must always do to the top. Very good. And when we multiply fractions, again, you just multiply straight across the top. So this will be 2 times the square root of 5 on the top. We write that as 2 root 5. You can leave a radical on the top. You can't leave one on the bottom. So let's make sure you understand this. What if it were like the square root of 3 on the bottom of a fraction? What would you do? Yeah, very good. Let's take it a step further. What if it were the square root of 4 on the bottom of the fraction? What would you do? It'd be 2. Yeah, so don't do this if you don't have to. It is an extra step. You want to avoid it if you can, right? So don't be a robot. If it's something that's perfect square, just simplify the square root. Questions about that? Alrighty. So let's use this in today's lesson a little bit. Again, our goal for today, we solve for x. Oh, we won't. We get x by itself. So when you take a look at part A, I have 4x squared equals 12. And I'm going to solve this by undoing. I'm not going to get one side equal to 0 and try to factor and solve. I'm going to undo this one. So when I think about it, I'm thinking about SADMAP. I have to undo any subtraction or addition that I see in the problem. I don't see any. So I'm going to go on to the next, which would be division or multiplication. I do see that, do you? It's not written, but 4 times x squared is what's occurring on that left side. I'm going to copy my problem for a second. I'm going to divide both sides by 4 to get rid of the multiplication. Simplify the right side. 12 divided by 4 is 3. Honestly, I could think of 2 numbers I could square that would give me 3 back out. 2 of them. So I'm going to square root both sides. But I know that there's 2 different things I could square to get 3 back out. What I'm trying to say is there's a symbol that goes in front of my answer right now. Does anybody know what it is? Hannah. Yeah, very good. Plus or minus. Do you remember that? A little bit. I have 2 answers here. I have the positive square root of 3 and the negative square root of 3. And let me just talk briefly about why I have to include both. If I square the positive square root of 3, I get 3 back out. Because the square root of 3 times the square root of 3 is 3. If I square the negative square root of 3, that's negative root 3 times negative root 3. That's also positive 3. So you need to make sure that when you go to square root both sides, you include that plus or minus in your answer. I did want to take a moment just to verify this on my calculator. First thing I'm going to do is I'm going to see what the square root of 3 is as a decimal. So the square root of 3 as a decimal is about 1.73. Now what I'm going to go ahead and do is do what you did on your homework or in your notes last night. In my y equals screen, you'll see I already have entered y equals 4x squared. The left side of your equation you enter into y1. And then in y2 I entered 12. And now I'm going to press graph. Keep in mind this is not Zoom standard. Zoom standard only goes up to 10. But I had to get that horizontal line at 12. So I did adjust my window. I stretched out my y max to see that to 15. I'd like you to do this now, please. We're verifying. See how it says in your notes we're supposed to check it with a calculator? This is how you would go through and do that. Do you see how this U-shaped graph, called a parabola, runs into that horizontal line, not once but twice, that means that I'm thinking I'm right, because I had a positive square root of 3 as one answer, and a negative square root of 3 is the other. Does anybody need help getting their graph to show up? So, can anybody walk me through the steps that I walked you through last night? How do you check this on a calculator? Go ahead, Tamara. Very good. Yeah, very good. So just basically hit enter 3 times. Look at that. Negative 1.73. That's the negative square root of 3, right? So we did it. Good job. If I go ahead and check the other one, second calc, option 5. I'm going to scroll over a little bit. I'm really hoping I get positive 1.73, or that positive square root of 3. So enter, enter, enter again. Look at that. Square root of 3. So do you see how there's 2 spots or 2 answers I'm looking for? Does that make sense? So we did it right. We got that matching decimal answer that corresponded to our radical. Good job. All right, let's do it again. Part B. We have x minus 3 quantity squared equals 7. So I'm going to go backwards through that order of operations. Careful. The first step is to undo any subtraction or addition that you see in the problem. So would I start this by adding 3 to both sides? No, why not, David? You're right. Yeah, it's that mep. So the parentheses, that minus 3 that's in the parentheses, comes at the very end. So I would not start this problem by adding 3 to both sides. I would actually just go right to the e, right? Got to undo the exponent. So I'm going to square root both sides first. So I have x minus 3 equals plus or minus the square root of 7. Then I can get rid of that minus 3. Add 3 to both sides. We get 3 plus or minus the square root of 7. Typically we write this in 2 different answers so that we could check both decimals on the calculator. One of my answers is 3 plus the square root of 7. The other one is 3 minus the square root of 7. And I'll go ahead and get those decimal approximations on my calculator. So 3 plus the square root of 7 and 3 minus the square root of 7. So I'm looking, if I'm going to check this in a calculator, I'm looking for about 5.65 and 0.35, about. So now we can go into our calculators and check to make sure that indeed these are our points of intersection. So we have x minus 3 squared and then on the right side that was equal to 7. Check that out. That's a parabola moved to the right 3 spaces. X minus 3 in parentheses. Moved it to the right 3 spaces. That'll come up at the end of the chapter. We'll talk about that later. But yeah, do you see how it hits in 2 spots? So now we're going to go back and just make sure that those 2 spots match about 5.65 and 0.35. So second calc, option 5. I get kind of close to it if I can, and then I hit enter 3 times. Look at that! Do it again on the other side. So second calc, option 5. Get a little closer there. 5.65. We did it. Questions about this so far? So y1 is always the left side of your equal sign. Y2 is the right side of your equal sign. Ultimately, when we're sending these two sides equal to each other. We're just finding the place where they meet. Anything else? Alrighty. So now we have a couple more. This time around we're going to be able to check them with substitution. But the process is still the same. We're going to go ahead and take a moment to undo this with that. So I undo any subtraction or addition that I see in the problem. Essentially I see this minus 100 here, so I'm going to add 100 to both sides. So I have x minus 5 squared equals 100 square root. So I have x minus 5 equals square root of 100. Ooh. Not 10. We're trying to solve for x. How many answers are going to satisfy this equation? Plus or minus 10. Watch out for that. Everybody see why we need the plus or minus? There's going to be two answers that work here. Wait, make sure we get both. Add 5 to both sides. So we have 5 plus or minus 10. And again, you're going to see that whenever I have that plus or minus business, I like shoot some arrows out of my answer. So what I'm thinking about right now is doing 5 plus 10 and 5 minus 10. So when I simplify these expressions, 5 plus 10 is 15. 5 minus 10 is negative 5. And you can plug them in to the original equation. If I do 15 minus 5, that's 10. 10 squared is 100 minus 100. Oh yeah, that's 0. Negative 5 minus 5 is negative 10. Square it up, you get 100. 100 minus 100 is 0. So both of those answers work. Questions about that? Okay, one more and then you get to try. Do you see how there's a fraction in this one? How do you get rid of that 1/4? Yeah, very good. So I am going to multiply the entire problem by 4. Multiply on the left side, multiply on the right side. 1/4 of 4 is 1. So now I have x minus 6 squared equals 36. Square root both sides. Get rid of the squared, because the square and the square root undo each other. Square root of 36, be careful. Plus or minus 6, very good. And we add 6 to both sides. I now have to think like, oh, these are just two numbers. What are those numbers? To think about those numbers, I do 6 plus 6. And then I have to do 6 minus 6. Well, 6 plus 6 is 12, but 6 minus 6 is 0. So I plug them back in. 12 minus 6 is 6. Squared up, that's 36. 1/4 of that is 9, so that works. And then 0 minus 6, that's negative 6. Squared up, that's 36. 1/4 of that is also 9. So these also both work. I just want you to try 1 on the next set. And then B and C you're actually going to save before your notebook quiz. You'll fill those in. I just want you to try part A to make sure you understand the process. I'll press pause. Yeah, every once in a while I will see students try to distribute this 2 in to this set of parentheses right there. Are you allowed to do that? No? Okay, why? Why can't you just distribute that 2 in? Yeah, you would have to know what that x value were first to do the exponent before you multiply. It's essentially just a violation of the order of operations. You can't distribute that 2 in without knowing what x is. So the idea is that we peel off the layers in this lesson to get down to the x. It's kind of like you're peeling an onion, and the right side of the equal sign is your garbage can. So you're constantly like taking something off of the onion on the left side and putting it in the trash can on the right side. That's how sometimes teach that for like algebra 1. Garbage can. Something we're trying to peel. Take the outermost layers off, put them in the rubbish. Questions about that? So you peel off the 2, you don't put it in. Alright. So an application problem. You got your first word problem last night. I'll go ahead and be honest with you. We only do, depending on how you look at it, 3 different types of word problems in this chapter. The first one was geometry. That was last night. You had to work with the area of a rectangle. The second one, dropping and throwing stuff. We actually have a little physics problem here. This is the formula for projectile motion. And just to talk with you briefly about this particular problem, we have a water balloon and we're dropping it from a height of 59 feet above the sidewalk. We're supposed to figure out, Linky, how much time it takes for the water balloon to hit the sidewalk. Now, before I get too far into the word problem, I just want to talk about what this formula means. What are all those letters? Like, what's the H and the B and all that? H of T. Whoops. Sorry, I didn't mean to make you seasick. Okay. H of T is the height, typically in feet, after T seconds goes by. T in the problem, that negative 16 is always there. It's part of the formula. T is going to be time in seconds. V is the initial velocity exerted on the object. Oh, wait. Stop writing. Look up for 1 second. We talk about two different types of problems that use this formula. Sometimes I throw something. Sometimes I drop something. I'm about to drop this marker right now. Are you ready? Super exciting. I need to know its initial velocity or Selena could just drop it. She was doing it for me back there. What is the initial velocity on this object right now? Ah, very good. I almost dropped it, but I didn't really have to because you all got the answer before I dropped it. If I drop something, there is no initial velocity for this object. But if I throw it and I exert some force on the object first, they'll say in the problem, oh, it's thrown at 112 feet per second, something like that. So if they put some sort of force on the object, they'll give you the velocity in the problem. Do you see what type of problem we're dealing with here, though? Ooh, we're going to drop something. So we'll talk about that in just a minute. You need to know that V is the velocity of the object, the initial velocity on the object. And then H sub 0, I always think 0 is like original. This is the original height. Some books will write this as an S, and they say, oh, it's the initial position. But we'll just call it the original height. So this is your verbal model. This is your formula. This is what you're going to use. So now we make a list of the things that we know and the things that we don't. Can anybody help me fill in anything I know about these letters in the problem? Go ahead, Dom. Yep, very good. Anybody know anything else? Yeah, why is the velocity 0? You're right. Because you're dropping it. Very good. Way to pay attention to that. So initial velocity, because I dropped the object, is 0 feet per second. Brian. So that's this. So the final height, you were probably thinking about this one. The final height of the object, it has to hit the ground. What's the height of the ground, Eric? 0. Do we know the time? No. So this is our question mark right now. Does everybody see why we put in 0 for H of T? This is function notation, by the way, f of x. You don't do anything with the h times t. Okay, so now it's kind of like plug and chug. H of t becomes 0. I don't know what t is. V is 0 because we're dropping the object, and the initial position is 59. I could simplify this equation. Do you see I have 0 times t in there? 0 times t, that's just 0, so that goes away. My equation is actually negative 16t squared plus 59 equals 0. And I could solve this by undoing. If it bothers you that the variable's on the right side of the equal sign, you could reverse this equation. I'm going to work with it as is. So I would subtract 59 from both sides. And typically I say no decimals, unless we're doing a problem like this where I want to know how many seconds is it. So we are going to use decimals just a little bit. I would divide both sides by negative 16. And then, we did this one a little earlier. I would take that negative 59 and divide it by negative 16. For the sake of the problem, I would go ahead and round that. Actually, I don't have to round that, do I? 3.6875. My old brain will remember that. I would then square root both sides. I want to show you a trick on your calculator to get this really nice and precise. If you press second square root, second answer, which is right above your negative sign right there, you don't have to type all of those glorious decimals in there. It'll paste it right underneath that radical. Do I need the plus or minus? So I got 1.92. I heard a bunch of no's on this side of the room. Anybody want to elaborate why I don't need the plus or minus all of a sudden? We're dealing with time, yeah. Yeah, I do understand it's like the 30th anniversary of Back to the Future, but we will not be going back in time in Algebra 2 class. You don't need your plus or minus. I'm going to make an approximation, so I use the wavy symbol. It's about 1.92 seconds. But yeah. Does anybody have problems with their calculator with respect to this? You do have a couple of conclusion questions to start thinking about. I'll use them to kind of bridge us into tomorrow's lesson a little bit, where we start our third method, completing the square. So I just want you to kind of think about these before you leave me today. Or you just beep. You have book work tonight. It's going to take you some time. Make sure you check your odds in the back of the book. And then if you want to take advantage of the buybacks, that paper's on the back. Don't forget to grab it on your way out.